Hi everyone, I am Dr. Ravichandar Janapati, Professor of EC Department, SR University, Warangal. In today's lecture, we will discuss reference models. We have two reference models. One is OSI, that stands for Open System Interconnection Reference Model. Another one, TCP/IP reference model, Transmission Control Protocol / Internet Protocol reference model. Now, first we will discuss OSI reference model. So first we will discuss the background of OSI reference model. Then we will discuss the OSI reference model and its layers. An ISO, that is International Standard Organization, that covers all aspects of network communication, is the Open System Interconnection Reference Model. An open system is a model that allows any two different systems to communicate regardless of their underlying architecture. So that's what we can call it as a open system interconnection model. If they have two different architectures also, they can able to communicate. So that is a open system interconnection reference model. That is called as a OSI reference model. Now, this OSI reference model, it is not a protocol. It is a model for understanding the designing a network architecture. It is model for understanding and designing a network architecture that is flexible, robust, and interoperable. So this OSI reference model is not a protocol. It is a model. It is a reference model which can allow two different architectures systems to communicate with each other. It allows two different systems can communicate with each other. So that's what we can call it as a open system reference model. It is a robust, flexible, and interoperable architecture. Now, first we will discuss the OSI model layered framework for the design of network system that allows for communication across all computer systems. So before that, we will discuss what is OSI reference model. I will correlate that with one example. Here I will correlate this OSI reference model with one example before that. So why we have to go for this layered framework? So if we have one task, then that can be divided into layers. So because of that, we can divide the given tasks into small tasks. So design of a network system that allows for communication across all types of computer systems. Now, for example, if one particular person here, Ramu is there. Ramu. Next, Raju. Here, I will explain with one real-time example. This is why we have to go for this layered architecture. Raju. So this Ramu, he is in Warangal. So this Raju in Chennai. Now, first of all, this Ramu want to send one postal letter to Raju. That is the task. So here, what is the task? Sending postal letter. Sending the postal letter. That is the task. Now, in this sending the postal letter from Ramu to Raju, here there are multiple tasks are involved. Multiple tasks are involved. For example, first this Ramu should write letter. First this side. Ramu side. First this Ramu side. He should write a letter. One. He should write letter. Second task, envelope. Keep it in that envelope and drop in box, nearest post box. So that is the task. Now after that, what he has to do? Now after that, he should write then after dropping third, this person or postman collect and central office. He will take it to central office. Central office. Then fourth one, after sending it to the post central office, then he will send that will be transmitted over some port mechanism from Warangal to Chennai. So these are the tasks involved. In the similar way, this is at Ramu side. Now Raju side, what he should do? What are the tasks involved at Raju side? So first, this postman collect letter, then central office, then after taking it to central office, then dispatch to local post office, then from that local post office to it will reach to Raju. So these are the things, task involved from sender side as well as receiver side. So in posting one letter, the posting of one letter, it consists of multiple tasks. So we have to divide our tasks into different, one task into different subtasks. So in the similar way, in OSI reference model also, here the given task here in OSI reference model also, the given task, it can be divided into multiple tasks. So that is the thing now we are discussing. So in the similar way, here that given task is divided into subtasks. In the similar way, we will discuss vegetable vending. So another example to vegetables vending, vegetable here marketing. So in this vegetable marketing, first farmer, he will just cultivate the vegetables. Then after that, he will, one local person or middle merchant will come to him and he will bargain and he will take it to the market. So from that market, central market, another local vendors, they will purchase and they will distribute it to, distributor means we all people can purchase from them, that local vendors. So this is the procedure in vegetable marketing. At the sender side, first here you will cultivate, then you will first next will middle merchant will purchase and he will give it to the local merchant. Then another side here he will local vendors, they will purchase and they will, and these users like us will go and purchase that vegetables. So these are the things that will happen when we are taking vegetable marketing. So in the similar way, in vegetable, in similar way, in OSI reference model also, here, in OSI reference model also, we have to divide the given task into subtasks. That subtasks are called as layers. Now we will discuss the OSI model. So this OSI model is built upon 7 order layers and which can be divided into 7 layers, which are layer 1, physical layer, layer 2, data link layer, layer 3, network layer, layer 4, transport layer, layer 5, session layer, layer 6, presentation layer, layer 7, application layer. So in the similar way, we are dividing the given into different layers. First one in this layer, Layer 1 is physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. These are the 7 layers. OSI reference model consists of 7 layers. Now, here, it is a P2P communication. Here, the what is happening at the sender side, the same thing, it is also happening at the receiver side. Just like our postal communication, here also when we are sending email, and technically when we are sending the email, now we can imagine what other things can happen. Now we have different layers. One, application layer. Sorry. First we'll start with here. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Now we can have the same thing at the receiver side also. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Now when we are sending the information from one device to another device, the same device, the same layer, it will first at the receiver side, sender side, there is a communication between the sender side as well as receiver side. This is called as peer-to-peer communication or peer-to-peer protocol. Now, as well as there is a connection between this above and below layers. So this is called as interface. There is a connection between these two layers that is called as interface. So here interface, 3 to interface, 4-3 interface, 5-4 interface, 6-5 interface, 7-6 interface. So these are the interfaces. Now within a single machine, each layer calls upon services of the layer just below it. For example, layer 3 uses the services provided by layer 2 and provides the services to the layer 4. Each layer provides the services to its below layer. Between machines, layer X, one machine communicates with the layer X on another machine by using a protocol. This is called as peer-to-peer process. Just now we have discussed that. So the same layer on sender as well as receiver, same level, that is called as peer-to-peer process. And there is a service provided by layer to its below layer, that is called as interface, through the interface. Now the communication between machines is therefore a peer-to-peer process using protocols appropriate to a given layer. Communication between machines is therefore a peer-to-peer process using protocols appropriate to a given layer. Next, interface between layers. So there is an interface between each pair of the adjacent layers. This interface defines what information and services a layer must provide for the layer above it. So that is called as an interface. So this layer provides the services to its below layer, that is called as a interface or service. Now, first we will discuss one by one layer. First we will discuss the each layer. First one is physical layer. Physical layer is responsible for transmitting individual bits from one node to the next node. Physical layer is responsible for transmitting individual bits that should be in the form of bits that will be converted into signals. So what is the main job of the physical layer? These raw bits that will be converted into signals. That is the first job. And as well as it is responsible for transmitting individual bits in the form of signals. Next, the physical layer is concerned with the following. It characteristics of interface and medium. It defines the types of media, transmission media, whether wired media or wireless media. So it will define whether the given type of media, transmission media, whether it is wired or wireless. So that is the first characteristics of physical characteristics of interface. Next, another one is a representation of the bits. The physical layer data consists of a stream of bits 0, 1. The transmitted bits must be encoded into signals that are electrical or optical. The physical layer defines the type of encoding, and also it defines data rate, how much speed we are sending the information. So whether the sender as well as receiver, they are in synchronization or not. This is also responsibility of the physical layer. And also the representation of the bits. The physical layer stream of bits, the transmitted bit is encoded into signals that are electrical or optical. Now, this is also another responsibility of the physical layer. One is line configuration. Line configuration means the physical layer is concerned with the connection of devices. In what topology they have connected, whether it is ring, star, or bus. So what a type of topology. Each topology is having its own advantage as well as disadvantage that we have discussed. Next, another one, transmission mode of transmission. Transmission mode. As already we know that there are different modes of transmission. One is simplex, half duplex, full duplex. So this also defines the transmission mode. One is simplex, half duplex, full duplex. What is meant by simplex? Only one way of communication. Half duplex means in both direction but not at the same time. Full duplex means in both direction at the same time. So it is next, another one is data link layer. Data link layer. It is this data link layer is responsible for data link layer is responsible for node to node delivery of data. Data link layer is responsible for node to node delivery of the data. Now here the for transmitting the bits from node to its adjacent nodes, that is called as data link layer. That is the responsibility of the data link layer. So from network layer, this is the data link layer. Now we get this data link layer is responsible for node to node delivery of the data. Now framing. The first responsibilities of data link layer is framing. The data link layer divides the stream of bits received from the network layer into data units called frames. The data link layer divides the stream of bits received from the network layer into data units called frames. So it divides the data stream of bits, raw bits, into frames. First one, physical addressing. If the frames are to be distributed to different systems on the network, the data link layer adds a header to the frame to define the physical address of the sender, source address, and our receiver destination address of the frame. If frames are to be distributed to different systems on the network, the data link layer adds a header to frame to define the physical address of the sender, that is source address as well as destination address. It is already we have discussed, it is responsible for node to node delivery of the data. If the frame is intended for a system outside the sender's network, the receiver address is the address of the device that connects one network to the next. So it consists of another address that is called as network address. Now, this is the example of data link layer addressing. So here we have trailer. This is the data. This is the source address. This is the destination address. So the source 10 want to send information to this 87. Then first it will send the data. It will arrange in a frame format. First trailer, usually error detection and correction. Then data. Then source address. Then destination address. These are the things normally happen. Next, another one is flow control. Data link layer is also responsible for flow control. The data are absorbed by the receiver is less than the rate produced in the sender. The data link layer imposes a flow control mechanism to prevent overwhelming of the receiver. So, for example, the sender is sending the data with 100 kbps, but the receiver is receiving to only 10 kbps. Then what will happen? Overflow will occur. So, to avoid that, we have to use flow control mechanisms. Next, another one is error control. Error control means the data link layer adds error detection as well as correction methods like CRC, cyclic redundancy check, FCS, frame check sequence, as well as parity check. These are the different methods it will add. The data link layer adds a reliability to the physical layer by adding mechanisms to detect and retransmit a damaged or lost frames. Error control is normally achieved through a trailer to the end of the frame. The data link layer adds a reliability to the physical layer by adding mechanisms to detect and retransmit damaged or lost frames. Error control is normally achieved through a trailer to the end of the frame. Next, another one is access control. When two or more devices are connected to the same link, and data link layer is responsible for determine which device has control over the link at that time. So this is the access control. This is also responsibility of the data link layer. Next, another layer is network layer. Next, another layer is network layer. Network layer means here now we will discuss another layer, that is network layer. This network layer is responsible for source to destination delivery of packet possible across multiple networks. In the previous, data link layer is responsible for within the network for data transmission it is responsible. But here this network layer is responsible for the source to destination delivery of a packet. So one source to next destination delivery of packet possible across multiple networks. It converts frames into packets. It converts frames into packets. If two systems are connected to the same link, there is usually no need for a network layer. If two systems are connected in the same link or same network, no need for network. However, if the two attached to a different networks, there is if attached to a different networks, there is often a need for the network layer to accomplish source to destination delivery. So the network layer is responsible for source to destination delivery of the packet possible across multiple networks. It converts frames into packets. Now, the functions of network layer. One is logical addressing. Logical addressing. This is also, or it is also known as network addressing. If packet crosses the network boundary, we need another addressing called logical addressing. This is called as IP addressing or network addressing. So that is the responsibility of the network layer. In the network layer, we need logical addressing. So in the logical addressing, we need physical addressing may change, handle addressing problems locally. If packet network boundary, we need another addressing called logical addressing that never change. So usually routing, route the packet to final destination. The network layer is responsible for the delivery of packets from source to destination. This is the important, we have to remember. Next, another layer is transport layer. Transport layer. The transport layer is responsible for process to process or end to end delivery of the entire message. The transport layer is responsible for process to process or end to end delivery of the entire message. So the network layer oversees host to destination delivery of individual packets. The network layer oversees host to destination delivery of individual packets. It does not recognize any relationship between those packets. The network layer is responsible for, transport layer is responsible for process to process or end to end delivery of the data. End to end delivery of the data, that is the responsibility of the transport layer. The network layer oversees host to destination delivery of individual packets. It does not recognize any relationship between those packets. The transport layer ensures that the whole message arrives intact and in order, overseeing both error control and flow control at the process to process delivery of the data. So the transport layer is responsible for process to process delivery of data or end to end delivery of the entire message. The network layer oversees host to destination delivery of individual packets. It does not recognize any relationship between those hosts or packets. Now the transport layer ensures the whole message arrives intact in order, overseeing both error control and flow control. So this is transport layer. The transport layer is responsible for delivery of a message from one process to another process. The transport layer is responsible for delivery of a message from one process to another process. Next, another layer is transport layer functions. So this is the functions of transport layer. Service point addressing are called as port address. So there are multiple ports are running on a device. So for example, even though if we have one particular device, once the message receives by particular device, then there are multiple ports are there. So in which port we have to address? That is the responsibility of the transport layer. That is the responsibility of the transport layer. That address is known as port address. That address is known as port address. So the network layer gets each packet to get the correct computer. The transport layer gets the entire message to the correct process on that computer. The network layer gets each packet to the correct computer. The transport layer gets the entire message to the correct process. Next, another one, that is segmentation and reassembly. A message is divided into transmittable segments. In a transport layer, the message is divided into transmittable segments, each having sequence number, each having a sequence number. These numbers enable the transport layer to reassemble the message correctly upon arrival at the destination. Now we have connection control. The transport layer can be either connectionless or connection oriented. The transport layer is connectionless or connection oriented. Connectionless transport layer treats each segment as an independent packet and delivers it to the transport layer at the destination machine. A connectionless transport layer treats each segment as an independent packet and delivers it to the transport layer at the destination machine. Now, Coming to connection-oriented transport layer, it makes a connection with the transport layer at the destination machine first before delivering the packets. After all data are transferred, the connection is terminated. So this is the responsibility of the transport layer. Next, flow control. Next, transport layer is also responsible for flow control. End to end. This flow control is responsibility of the data link layer, but that is from adjacent layers. But in transport layer, this is the end-to-end device flow control. The data link layer performs flow control across a single link or within the network, but it is from end to end. Next, error control. The transport layer performs error control end to end. The data link layer performs control across a single layer. Next, congestion control. Another important task is congestion control. Concerns the controlling traffic entry into a telecommunication networks. So avoid congestive collapse by attempting to avoid oversubscription of any the processing or link capabilities of the intermediate node and networks and taking resource reducing steps such as reducing the rate of sending packets. It should not be confused with flow control, which prevents the sender from overwhelming the receiver. So this congestion control means here when load on the network it is greater than the capacity of the network, that is called as a congestion. When the load on the network, if it is greater than the capacity of the network, that is called as a congestion. Congestion, we need to control that congestion. So it is concerned controlling traffic entry into a network. Let us take that example. Now, here if it is more, then we have to avoid that. There are open loop congestion control, closed loop congestion control methods are there. Now, session layer. Next, another layer is that is session layer. Session layer is responsible for dialog control and synchronization. The session layer is responsible for dialog control and synchronization. It is from presentation layer. So it will take the data from presentation layer and it will useful for the main responsibility for dialog control and synchronization. So functions of session layer. One is the decision control, that is half duplex, full duplex. Synchronization, adding checkpoints to stream data. System sending 2000 pages. Add checkpoint after each 100th page. So that is the responsibility of the session layer. Decision control, synchronization. Next, another one is presentation layer. Presentation layer, it is concerned with syntax and semantics of the information exchanged between two devices. So that is the responsibility of the presentation layer. Syntax as well as semantics. So how we are going to present? So it is a user interface. Normally it is a user interface. Now it is application layer. Below layer is presentation layer. Now functions of presentation layer. One is translation, interoperability between different encoding formats, That means we have to translate between the sender as well as receiver, interoperate between different encoding formats. Different sender is following one encoding format, the receiver is following another encoding format. So to provide interoperability in these two devices, we use translation. Next one is encryption, which is very important security, converting a plain text to a ciphertext and vice versa. Encryption as well as decryption. Next, another one is compression, that is reducing number of bits in multimedia data when streaming. That is also compression. Next, another one is application layer. Final layer is application layer. The application layer is responsible for providing services to the user. So it provides services to the user. So here, one user is here, another user is here. So it provides services to the user. Now, functions of application layer provides user access to the network, X500 directory service. So these are the different protocols or files. TAM, file transfer access and management, network virtual terminal. So these are the different protocols we are using here. Now, up to now, we have discussed the OSI reference model. OSI stands for Open System Interconnection Reference Model. In this reference model, we have 7 layers that are physical layer, data link layer, network layer, transport layer, session layer, presentation layer. These are the 7 layers. These are the 7 layers in a OSI reference model. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. So this each layer description also we have discussed. Now we will discuss another reference model, that is TCP/IP protocol, transmission control protocol, transmission control protocol slash IP protocol. It is a transmission control protocol slash internet networking protocol is used in the internet, is developed prior to the OSI model. Not match exactly with OSI model, it is divided into sublayers. Transmission control protocol slash internet protocol. It is a practical approachable. That OSI reference model theoretically we can implement, but this TCP/IP reference model is a practical approach. It would not match exactly with OSI model. It is divided into layers. Now it will combine some layers into single layer. Now if you observe TCP/IP reference model, we have 5 layers. In some textbook, it will give 4 layers, but here physical layer, data link layer. So this is one layer, or we can call it as a 2 layers also in sometimes. Next one is network layer, transport layer. This session presentation application, this is called as application layer. This is called as transport layer. This is called as network layer. This is called as physical layer. So physical layer, network layer, transport layer, application layer. So these are the 4 layers. So already we know that the responsibility of the physical layer, it is used for flow control. Sorry, physical layer, it is responsible for raw bits of transmission that converts bits into signals. Then data link layer is responsible for stream of flow control as well as error control mechanism. Then network layer is responsible for source to destination delivery of the data. Transport layer is responsible for process to process delivery of the data. System layer is responsible for system layer, presentation layer, application layer is responsible for transmitting or transporting the information. So it is a user interface protocol. In this, we have in physical layer and data link layer, we have protocols defined by the underlying networks. Now, network layer consists of different protocols that are ICMP, Internet Control Message Protocol, IGMP, that stands for Internet Group Message Protocol, Internet Protocol IP stands for Internet Protocol, ARP stands for Address Resolution Protocol, RARP is used for Reverse Address Resolution Protocol. Next, transport layer, it consists of 2 different protocols. One is Transmission Control Protocol, that is TCP. Another one is UDP, that is User Datagram Protocol. Next, this application layer consists of different protocols which can be directly deal with the users: SMTP, FTP, Telnet, DNS, SNMP, NFS, TFTP. These are the different protocols that can be used by TCP/IP reference model in application layer. It contains relatively independent protocols that can be mixed and matched with the depend on the need of the system. So this is regarding TCP/IP reference model. TCP/IP reference model is it is similar to OSI reference model, but it is practical implementation. Nowadays, we are using this TCP/IP reference model. OSI reference model is a theoretical version, but TCP/IP is a practical version, and it consists of 4 layers, which in that 7 layers, some layers are combined into different layers. Now, in this lecture, we have covered one is OSI reference model, another one is TCP/IP reference model. Thank you.